Hi viewers, welcome to our channel. This is Kishore Palavalsa. Please subscribe our channel. Till now anyone not subscribed, and also I need your encouragement. I need your always support. Okay, so thank you one and all. Thank you. So till today now we are going to discussing about rating of transformer, and also there are different types of losses also we are considering today. Okay. So coming to the first of all rating of transformer. Coming to the rating of transformer. So basically the transformer rating which is measured in KVA, KVA means kilovolt ampere. Kilovolt amperes. Basically we have to represent in terms of kilovolt ampere. Okay. Means here V means here voltage. Here V means voltage, A means ampere. Why? Because how can we justify this KVA? The transformer rating measured in. So simply you can say that in case of transformer, the iron losses, basically there are two types of losses in there in the transformer. One is the iron losses and second one is the copper losses. Okay. So in that, so first of all the iron losses which is majorly based on the voltage. The iron losses which is majorly based on the voltage, and also the copper losses which is based on the current. The copper losses which is based on the current. So that's why the transformer rating which is measured in terms of KVA. So that's why the transformer rating which is measured in kilovolt ampere. Okay. Here the iron losses which is depending upon the voltage, as well as the copper losses which is depending upon the current. So that's why the transformer rating which is measured in KVA. Okay. And also coming for the losses in the transformer, basically there are two types of losses will be occurring in the transformer. Okay. In that one is the iron losses. Okay. In that one is the iron losses, and second one is the copper losses. Okay. So basically here the iron losses also called as like a core losses. The iron loss also called as core losses. Why? Because here the total material which is manufactured by core. So that's why in that core basically produced as a iron losses. So that's why simply you can say that iron losses also called as core losses. Okay. And also coming for the copper losses. So copper means here basically in the transformer we are using, there are different types of windings. One is the like primary winding, and second one is the like a secondary winding. Simply we can call it as like that. So both windings which is manufactured by copper. Both windings which is manufactured by copper. So in that copper, so generally produced as a copper losses. Okay. So coming for the basically iron losses here. Okay. The iron, whenever first of all here those two losses. Okay. Here both iron losses as well as copper losses which is mostly occurred according to the connection of load. According to the connection of load to the transformer. So generally basically produce as a both iron losses as well as copper losses. Okay. Here load means like a consumer. Here load means like a consumer demand or like a load demand. Okay. So that is like either domestic or commercial or industrial purpose or hospital purpose or agriculture purpose, whatever may be the different types of, with the help of various loads, generally mostly rising to the all those losses. So coming for the first of all iron losses here. So the iron losses which is mostly based on here. So here without we are connecting any type of load. Here without we are connecting to the any type of load to the transformer, but iron loss also occurring here. Here we can't connect any type of load. Okay. Why? Because here okay basically the iron losses which is produced due to improper lamination of total core of the transformer. Due to improper lamination of total core of the transformer means. So for example, let us consider if the transformer lamination which is not to with the help of CRGO material made to like that. So then only, so basically between the one plate to another plate, like this, there are the core material may be contains. There are different types of number of, so like a laminations like this. In this laminations, if suppose if you want to not proper make one lamination to one plate to another plate, so there may be some air gap is there between one plate to another plate due to improper lamination with the help of CRGO material. Okay, which is very important. CRGO material. GO material. Okay. So CRGO means here C means cold. C means cold. COLLED cold. R means rolled. Cold rolled. Here G means grain. G means grain. O means oriented. O means oriented. Silicon steel. Silicon steel. Okay. So with the help of this material we can properly laminate it to the one plate to another plate to the total entire core of the transformer. So for example, if it doesn't using so this type of CRGO material, there may be some air gap will be existing between the one plate to another plate of so transformer. There may be occurred as like a iron loss. Why? Because in that iron core material some flux will be evaporated outermost of the atmosphere. Due to that resultant some iron loss also existing here. Okay. And also so coming for the here, so here coming to the here iron losses. So in that iron losses basically we have to classify into two types. One is the hysteresis losses, one is the hysteresis losses, and second one is the eddy current losses. And second one is the eddy current losses. Okay, which are very very important. One is the hysteresis losses and second one is the eddy current losses. If suppose if you want to go for the hysteresis losses, if suppose for example if we want to made one transformer, let us consider like that. So the transformer iron material which is the coefficient of material, the coefficient of hysteresis means the hysteresis coefficient of material which may contains higher level, then automatically the losses will be very high. Then automatically the hysteresis losses is high in the particular core material. Okay. ఎప్పుడు కానీ మనకి ఆ హిస్టరీసెస్ కోఎఫిషియంట్ వాల్యూ అనేది మనకి తక్కువ ఉండేటట్టు చూసుకోవాలి ట్రాన్స్ఫార్మర్. అప్పుడే మనకి సో ప్రాపర్గా మెకానికల్గా స్ట్రాంగ్ ఉంటుంది మనకి పర్టికులర్ ఐరన్ మెటీరియల్. సో దట్ ఈస్ వెరీ యూస్ఫుల్ ఫర్ ద in case of construction of transformer. Okay. And also coming for the eddy current losses here, coming for the eddy current losses here. So here basically the eddy current losses which is produced due to improper of lamination. Already we are learning before, due to improper lamination of transformer overall iron core. Okay. So if suppose improper, then what happened here? So then automatically the total flux which is existing in that particular so internal so transformer that can be evaporated outermost of the atmosphere. So then only basically eddy current losses also here existing. Here eddy current means that is like a leakage current. Okay, eddy current means here like a leakage currents which is exist outermost of the atmosphere, means like a weather condition. Okay. And also coming for the here copper losses. The copper losses basically producing so due to the copper material. Copper means here generally if you want to go for the transformer, both winding, both primary and secondary winding which is made by copper. Okay, due to whenever the load is connecting here, whenever the load here taken to the consideration for the load is very very important. Whenever we have to connect to the load, whenever we have to connect to the load, then automatically increasing to the copper losses. Due to increasing of gradually load, then automatically the copper loss is also increasing. The copper loss also increasing. But the iron loss is also constant here. But the copper losses is proportional to the load. So with the help of, with the changing of load, automatically the copper loss also increasing. Okay. Because, so basically the copper loss also we have to indicate as like a I square R losses. Which is indicated as like a I square R losses. That particular primary winding of the transformer, some losses also existing, that can be given as like a I1 square R losses. And also in case of secondary winding of the transformer, then also some losses also existing, that is we can simply judge as I2 square R losses. I2 square R losses. Okay, so these are the two types of losses which is existing in the transformer when we are connecting to the load. When we are connecting to the load, without load, so there is no generating of any type of copper losses. Okay, but the iron loss also constant. Because generation, if you want to connect to the load, either connecting to the load or not connecting to the load, that is not depends on to the iron losses. Okay, here iron loss is fixed. Here iron loss is fixed. Okay, so these are the different types of losses. And also here basically the transformer which is we can according to the construction we are to operating in the two modes operation. So one is the open circuit test and second one is the short circuit test. Coming to the open circuit test, here we doesn't connect to any type of load here. We doesn't connect to any type of load here. Here only we have to, in case of open circuit test, we have to only consider to the only iron losses only iron loss only considering here. Okay, because of short circuit test, so short circuit test means here the total secondary winding of the transformer which is connected to the load. The total secondary winding of the transformer which is connected to the load. At the time, what happened here? So basically, in the short circuit test, we have to find in the all different types of copper. All different types of copper loss also here finding here. Okay, so these are the basically representation of there are different types of all those losses as well as the rating of transformer we are learning today. Okay, so this is the today our class subscribers. If you have any doubt, please put on the comment box. I will give you reply each and every question. Okay, I need your support always. I need your encouragement also. Okay, thank you one and all. Thank you very much.